So, what is a function? You guys know? We've seen them in Algebra 1, Algebra 2, College Algebra, Calculus. What's a function? A function is where each input has exactly one output. Put a number in, you get a number out. You never get two answers. Remember, in a function, x never repeats. If you're looking at a graph, it passes the vertical line test. You never hit the same value more than once. We will use functions a lot in here. First thing, we're going to have to be able to read graphs. So I have a graph here and I just want to ask a bunch of questions about it. Find the values of f of 1 and f of 5. So when I say f of 1, that's like saying your x is 1. Tell me what your y is. So if I go to my graph, when my x is 1, what's my y value? 3. Okay, f of 5. So when my x is 5, so that's when x is 5. We're right here on the graph. What's my y? Negative 2/3 approximately, maybe, right? This would be like negative 1/2. So somewhere, we can't tell exactly, but this is close. Okay. What's the domain and range? Remember we did interval notation? Let's assume these are stopping points. Okay, so domain is talking about x. It goes from left to right. So what is my first x value? 0. And my last one? 7. Remember, if you touch them, does it get a parenthesis or a bracket? Bracket. If you hit it, it gets a bracket. If you don't, if it were like an open circle, it gets a parenthesis. That's my domain. Range is talking about your y's. So that's your lowest to your highest point. So my lowest point is negative 2. My highest point is 4. So range would be from negative 2 to 4. We hit the y values in between those. Everybody okay with these? Remember doing this a little bit? Local maximums and minimums. Okay. When I say local, that means it doesn't have to be the highest or lowest point on the entire graph, just higher or lower than the points around it. Okay. So do you see those also the local ones can't include endpoints? But I think we only have one local max here. Where is it? So 0.24. Where's my min? Okay. Yeah, I guess it may be a little past. Let's say 6.25. Okay, D, the roots or the zeros. What is a zero? Where it hits the axis. So this one hits the axis at approximately 4.7. Does it hit the axis anywhere else? At 7. You only have to give the x values there because we already know the y is 0. Where is the graph increasing or decreasing? So remember for these we gave intervals. This graph is increasing, so it's rising, starting when x is 0 until x is 2. And then what happens after 2? Decreases from 2 until we get to about, we called that 6.25. And then what happens after that? It increases again from 6.25 until, where does our graph end? 7. Do you guys remember doing those things on the graph before? Let's look at this one. So I'm going to give you a function and ask you some questions about it. All right, if I want f of -2, what do we need to do? So that just means you go to your equation and you replace all of these x's with a -2. So -2 squared is 4, times 3 is 12, it's 2 plus 2, and we get 16. B. F of a plus 1. So what do we do? Plug in an a plus 1 for everything. How do we deal with that a plus 1 squared? That means you have 2 of them. So you get a squared plus a, so that's plus 2a plus 1. I distribute that negative. So we get 3a squared plus 5a plus 4. Why don't you guys try the next two? F of 3a squared and f of a plus h. See if you can evaluate this. Okay, so f of 3a squared, when you square that part, you get 9a to the 4th. Multiply by 3, so you get 27a to the 4th minus 3a squared plus 2. Is that one okay? And D, f of a plus h. So when you do a plus h squared, you have to write it twice and FOIL it, so you get a squared plus 2ah plus h squared. So you end up with 3a squared plus 6ah plus 3h squared minus a minus h plus 2. So definitely easiest if we just have to plug in a number, but we can get answers when we are just evaluating by plugging in entire expressions. Any questions there? One thing that we will start doing a lot of in the coming weeks is what's called the difference quotient. So when we get to those sections, I'll introduce this again. You don't have to memorize this right now, but I am going to give you some problems and ask to find the difference quotient right now, because all it is really evaluating functions and simplifying, which is something we already know how to do. So let's just jot this down so we have it when I ask you to find. The difference quotient is this expression, f of a plus h minus f of a all over h. This has a very special purpose in calculus that we will see later, but right now I just want to make sure that we can handle the types of things that will come up when we start evaluating these. Do you not have your contacts again?
Yeah.
If I need to make something bigger, just tell me.
Oh, it's fine.
So let's just practice these. Okay, so first thing we have to do, we can do this all at once, especially in the beginning. I found sometimes it's easier for people to do it in pieces. So if I just asked you to find f of a plus h to begin with. We would get negative 4a minus 4h plus 5. What is f of a? Negative 4a plus 5. So the difference quotient is f of a plus h minus f of a all over h. So I plug those into that formula we wrote down. The f of a plus h minus our f of a divided by h. We can distribute this negative. What happens happens to negative 4a and positive 4a? Positive 5 and negative 5. Cancel. So we have negative 4h divided by h, which is negative. Final answer. And that will be the way on most of these that we have. They're going to have a lot of things that cancel out, and our answer will get prettier as we go on. Okay, B, f of a plus h. You can come out to the side and work that if you want. Whatever works for you. We're going to plug in a plus h for all those x's. To square that, we have to FOIL it, so you get a squared plus 2ah plus h squared. So that's my f of a plus h. Can I just do the difference quotient from here instead of rewriting all that? You guys okay with it? So difference quotient is f of a plus h, which is this thing, minus f of a, which would just be if you replace all of your x's with an a, over h. So if we run our negative through, 2a squared and negative 2a squared would drop out. Negative 5a and positive 5a drop out. Positive 1 and negative 1 drop out. Everything that we're left with on top has an h in it, so we could cancel an h out of everything. So my final answer is 4a plus 2h minus 5. How are we doing so far? Do you want to go ahead and do the last one and then stop here for today?
Yes.
Okay. So this one isn't too bad. We could jump right into that difference quotient. F of a plus h would be what? Just be negative 3 over a plus h. Minus f of a is just negative 3 over a divided by h.
No. Just gotta squint for a little bit to really get it.
Okay. This one is kind of ugly because we have fractions within fractions. And we know that's not okay. If we want to get rid of it, we have some options. In calculus, we're big kids now, we like to go to the shortest and fastest way to get to the end, right? So if I wanted to get rid of this denominator, a plus h, I would have to take everything times a plus h. If I want to get rid of that one, I have to take everything times a. But if I don't want to change my problem, if I do it on the top of the fraction, we have to do it on the bottom as well. So let's try. Let's see if we can do this in one step without confusing ourselves. I'm going to take top and bottom times a plus h times a. first one. The a plus h's cancel, so you're left with negative 3 times just the a. Minus, in this one, the a's would cancel, so we have the negative 3 times the a plus h. And on the bottom, we have all of it, an a, and an h, and an a plus h. So we kind of took one big leap and got rid of a lot of nastiness. Did everyone follow what we did there? So what I have is negative 3a plus 3a plus 3h for a times h times a plus h. Positive 3a and negative 3a cancel. And what else cancels out here? H drops. So our final answer is 3 over a times a plus h.